Alright, I noticed guys was a little laggy as well, so I'm going to show you D real quick. If we take this equation, if I label them again, equation 1, equation 2, and equation 3 with the same rules, right? So we can multiply or divide any equation by any number, and then we can add or subtract equations with the goal of removing variables, right? And then solving for a single variable. So we're going to do 2 steps and hopefully find either x, y, or z. And our first step, I noticed I could probably get rid of these x's pretty easy. Right? It wouldn't be much to make that into a 6x, and then they could cancel out with these guys. But I'm going to go with the y's. I think on my old video I might have gone with the x's actually, and it turned out pretty easy. But I'm going to go with the y's. I notice if I multiply this by -1, that's a positive 2y, and then both these negative 2's would cancel out if I added these equations 1 and 2 and 1 and 3. And that's my plan. My first plan is to take the opposite of equation 1 and add it to equation 2. That'll make these y's cancel out, right? Because the opposite of that's 2y, which will cancel out with -2y. So the opposite of this is positive 6, positive 2y, negative 2z equals positive 8. And then if I add that to equation 2, we got 3x minus 2y minus 4z equals 8. And we get 9x, the y's cancel out, negative 6z is 16. And we call that our new equation 4. All right, so we're going to use this later. I'm going to do the same thing again. We're going to say the opposite of equation 1 plus 3. Well, again, opposite of equation 1, same thing, 6x, 2y, negative 2z, and 8. And equation 3 is 6x minus 2y minus 6z equals negative 18. When I added those, well, the 6x's made a 12x, right? The z's here made a negative 8z. And 8 and negative 18 make negative 10. I noticed this guy reduced by 2. I thought that might be a good way to go, and I just divided everything by 2, right? 6x minus 4z equals negative 5. Now I got to get something else to cancel here, and I'm looking for common multiples. I know that if I could change this to a 12 and this to a 12, and then make sure they have opposite signs, my z's would cancel out. So what if I made this a positive 12 by taking my equation 4, the opposite of equation 4, right? Now we'll call this step 3. And we're going to add that to, well, that would make this the opposite. Oh, let's do more than that. We're going to have to double it too. So we're going to have the opposite of twice the equation 4. So the opposite of that would be 6z. Twice that would be 12z. Plus, and I need to bring this up to a negative 12z. So I'm going to say 3 times equation 5. So once again, we're going to do the opposite of twice equation 4 plus 3 times equation 5. So here we go. So if I double this, it's 18. The opposite of that is negative 18x. If I double this, it's 12. The opposite of that is positive 12 instead of negative 12. Equals, if I double this, that's 32. The opposite of that is negative 32. Let's go ahead and add that to 3 times this equation down here. Well, 3 times that is 18x. And 3 times that is negative 12z. I should put my z right there too. And all that's equal to 3 times that, which is negative 15. And lo and behold, the same thing happens on this as when I solve by x, obviously, because when I solve, everything cancels out. And I get z equals negative 47. And when you get a situation where you got a number that doesn't equal a number, and all the variables have already canceled out, we say no solution. A good opportunity to show you a couple others. If I ever get something like 3 equals 3, or very commonly 0 equals 0, that would be infinite number of solutions. That's just a review though. We're going to go back to this and say there's no solution. I'm going to highlight E. And E is hard, but give it a shot. All right. I would probably want to get rid of my x's because that's a 5x. And all I have to do is multiply these guys by 5. So I'm going to show you a first step you could do to get rid of the x's on, well, if you name these 1, right, 2, 3, I would probably do equation 1, like that, plus 5 times equation 2. And that would get rid of that x there. And then you could do the same thing here, equation 1 times 5 times 3. And then you only have y's and z's to work with. So try E. I know it's hard. It's supposed to be hard. Don't come in with that blank, and we can talk probably a little bit Monday and Tuesday about this. And we got one more to go, and we'll get these matrices. I might save these matrices to class because they're really super easy, but it's a lot of calculator work, and some of you guys don't have calculators. If you notice it on here, It's because I just think it should be up there for you guys to have access to, but I'm not going to do it right now.